Hello YouTube, fellow van lifers and fellow Victron enthusiasts, and even people that haven't got a clue with Victron gear. This should be a way for you to learn how to use nodered with the cerbogx and how powerful it is. It can clearly do many things easily, automated. The possibilities are limitless, really. It's pretty much down to your imagination. So to start off with, you need to be on this screen. This screen here is obviously my Cerbo screen, but I'm using it on the PC or the Apple. But first of all, click in the middle. I'm clicking on that. So click on your screen and then go to settings and then scroll down. It should be down the bottom. Integrations. So once you're on integrations, to see nodered here, which is enabled, first of all you need to go back to settings, general, and go to firmware and make sure you're on large image. If you're not on the large image, go down to install firmware from online updates, and then you can either have, I'm using the beta at the moment, but I've been doing a bit of testing, but click on image type and go from the normal to the large. Once you put the large one there, and then come back to here, check for updates. I do have an update, but I can't be bothered to do it at the moment. Then check for updates and it'll come up, and you probably get 3.80-14 if you're doing it now, but that number may change depending on what update there is. Once you've updated to the large firmware though, you will now see in integrations Signal K nodered. Make sure nodered is enabled. It may say disabled to start off with. If it does, don't worry. Come in here, click on enable on there, and then the easiest way, if you're using the computer instead of the screen, is to access nodered. Click open link. I've already got this open. When you open it, it's gonna ask you to set a password. If you're just using it locally and you're not going to be using it online, I would recommend setting a password anyway. But if as long as you're not using it online, then you don't need to set a password. But like I say, I'd always recommend, just in case someone jumps on your network and fiddles with anything. And then click on open link. Obviously that will open up a page. I have quite a bit of stuff going on in here. This is all to do with my tracker and display on the screen and how it takes the information. I'll explain a bit more about this node here in a minute, and all these nodes down the side, because these are all the stuff you can play with. There is more you can add in, but there's sufficient here to start you off. There is one node you will need to add in, and that would be the dashboard, if you so wish to have your own dashboard. Obviously if you're using a tracker, then you will need to have your own dashboard, and that's accessible. Again, I'll show you how to do that in a bit, but to start off with, I'm just going to create a new flow so we get blank information, and then I hit deploy. Any changes you make in nodered, you must deploy them, because if you leave the web page, the information is gone. So if you wrote out a script like this, where there's lots of stuff in here, there's a fair bit in here. I'll just show you. This is all to do with my Truma boiler. Yeah, it looks pretty complicated, but once you get the hang of things, you'll understand what's going on. So we'll go back to the flow 2 to start off with. Obviously I've got all these other flows going on with heating, MQTT, the Truma, and so on. But we'll start off with the basics, and then down here you've got all these Victron nodes. So Victron Energy, obviously of courtesy, have put some of these nodes on here for you to make things very simple. I mean, we'll start off with the Multi Plus. The Multi Plus, you come down to, we want an input. So see the little dot on the right hand side of the node here. That means it's going to input something in. So it's an input node. Has two selectable inputs, the device, measurements, and so on. So when I come down here, I'm just going to look for the node for the Multi Plus. It might be down as VE bus. It probably is, because it's a VE bus device. So you drag the node and plonk her in. I'll just zoom in a bit for that for you to make things a bit easier. Right, so now we've got this node here. There's a couple of little symbols above that node. We've got a red, which means there's some either configuration not set up or an error, and then a blue dot above means the node's been injected into the web page, but it's not been deployed. So that node at this moment, if I close this window now, that node will disappear. You hit deploy, and then because there's an error, it's asking you to pretty much go back or confirm about the error. I'm going to press cancel because I need to set that node up. So you double click on that node now, and now it'll bring up information what you want on the VE bus. So on the right hand side you've got either Multi Plus 2 or a Multi Plus 2000 and a 3000. I'm going to take some information from the 3000, and then it'll give you a measurement. The measurement is basically as you can see, you've got battery voltage, you can, all these different settings you can change on that Multi Plus, all from nodered, and do it automatically. So I'm going to go up here and I'm going to want AC output to inverter. No, I want, actually I know the Multi Plus 2 has got a temperature sensor on it, so, and I've put that, installed that. So we go to the Multi Plus. There should be a node in here for the temperature sensor alarm, the state charge, there's a lot of bits you can play with. High temperature sensor, high temp, probably under battery temperature. There we go, battery temperature. So now, to make things easier on yourself, instead of it just saying VE bus, you can say bat temp. So then you can do rounding, you can only changes, you can rate the amount of limit that comes in, you can have milliseconds, you can have 1 per second, 1 every 2 seconds. It all depends on what you need it to do. So you can change the limits and so on. Then you can make, so this is what's going to come out of that node. So if we deploy that now, save that, now deploy it. Now underneath that node we have that, we've got the battery temperature. So, but that's no good to us. I mean, we need a bit more information. So you can actually put a debug node in. It's right at the top. And again, drag a debug node in, and then bring the debug panel up, which should be here. And then you can draw a wire to that debug node. So anything that comes from this node here will come down this wire and into whatever device or whatever program you wish to do with. So to start off with is a debug node, so we can actually visualize it. in debug node you can either have just the message payload, or you can have the complete message object or the expression. So that's a JSON expression. To be honest, most of the time I just leave it on complete message object, so you've got all the information, you've got the topics, you've got everything to do with that data stream that's coming out of the Multiplus. And then click done, and now click deploy, and now what's coming through is the complete message object. So you've got the message ID, you've got the payload, which is 22.5, and you've got the battery, the topic. So when you name these, it puts a topic, and the topic can be referenced throughout the whole software. So you can say send the topic somewhere you only want to listen to this topic, or you only want to listen to something else, or the time. Plus inside that payload, so if we pause the data stream, so by clicking that little bit on the side, you haven't got to deploy at this stage, but by clicking that will stop any more data coming out. The data is still flowing, but we just don't need to see it anymore, because it's pretty much the same. So what can we do with this data? Well, you can, let's go to another one of my flows here. So you can have the information coming out of the Multiplus. Just connect that back up. V state. For some reason that's, there we go. So we've got the state, V bus state, so that's on the Multiplus. So what will come out of there will be a 0 for off, a 1 for low power, 2 for full, 3 for bulk, and so on. Basically, it's only going to give you numbers out of there, but it gives you the list of values. So if a number comes out of that, so my Multiplus is on 0 state. So what's 0 state? I think that's inverting, isn't it? So it's gone state 9, so inverting. So then, but only problem is 9 will come out of there. So you only go to change. So modes, payload, and then message topic, and then change. So what you do, the topic, because it come out as a topic in the payload. So instead of it having the payload, you ask it for the topic of the payload, and then it'll change it, and it'll change it into text. So anything of these numbers, and then it'll change the payload into one of these formats. So basically, you put let state equals so on, and then add all those in, and if that 0 or a 9 appears there, it gets passed through that, but then gets changed to on or inverting. If it's on, it's on. I should have had that as and then that'll come out to some information. So then you put that into a display node. So to access some bits, I'll have to show you that later, because I've got to show you how to install some bits first. So Victron doesn't actually come with a dashboard built in, so you would need to go over to manage palettes on the right hand side here, click manage palette, and then hit install, and then type dashboard. So I know this one's being got rid of because they want you to go over to nodered dashboard 2, but it is still supported and it still will work. So you just type dashboard in and then tick down here, and if you want to see any information about this dashboard, you click on there. It'll take you to a web page, and it'll show you what nodes are available and what you can do with that node and so on. And this is a quick show of what you can do with it. So we go back to the heater. So now that's installed, then this here is a inverter state, and it's for the state the inverter's in. It'll take the payload that you send into it and display it. So if we go to the right hand side here again, and then you've got dashboard, and then done, and then I want to go to that dashboard. So it's going to show you your state inverter on. So it'll put that on in there. I could go in here now and change that on to inverting. So if I, whatever text I put in here, so I can write inverting. Hit done, deploy, go back to the dashboard. Inverter is inverting. So depending on what state the inverter's in, it will display whatever you've put in your node in here, and it gets its information from the multiplus, which is on here. So don't always need to use the change node, but I find it's easier just to make sure it changes the values. So in other words, you won't get a value come out again until the value changes, because otherwise you'll end up basically getting so much data going across, it'll just wipe out any memory in your cerbogx. So you want to try and limit the amount of communications that are going on, unless it's absolutely essential. So again, you can go with the Venus system, Venus relays. I use that relay for, I can't remember, it's been a while since I've done some of these. Then you can get the Venus system battery voltage. So I've got it on the Venus system, which is the battery voltage. That what it does, it pulls that information from the Cerbo itself. So whatever the screen's displaying, that is what that will be. So the battery current amps, I'm pulling currently 7.8 amps, and if you look down here you can see it changing, but obviously there's quite a lot of decimal points sometimes. Don't worry about that, you can get that to do in here rounding, so you can go rounding 2 digits, 3 digits, it depends on your granularity you want. So if I click that, done, deploy, now it's only come down to 3 digits, so it will stay lower or whatever. So whatever you want, whether you only want 1 digit, 2 digits, 3 digits. And again, you can rate limit it in here as well. So 1 message per second, 1 message per 2 seconds. So it all depends on how fast you need them, the updated messages, and depends on what you're doing. Plus I've got a router on my van that's got a GPS built into it. That router also has an aerial on the roof, and I like to track all of what I do, where I travel, and it can overlay it on a map. So what it'll do, if we go to here, I send to the Cerbo via a TCP port. If you don't really understand TCP ports, it's just a way computers talk to each other. So if I send on my router to the 192.168.1.195 and then a semicolon, port 6666, and then I listen on this on the Cerbo, I listen on port 666. I don't need any IP addresses or anything, and it's a stream of strings that comes through, Each string is a payload. This is interesting. This is a bit more interesting than what I was showing a minute ago. Why has that done that? Alright, so the stream of data will come in. So let's just go back to the debug screen. And this is the stream of data coming through. That's just, be brutally honest, that is just not readable unless you're some sort of total computer geek. Even I struggle to understand what's going on there. I know it's a stream of data. It clearly looks like a stream of data. And fortunately, I knew it was an NMEA GPS stream of data because my router actually showed me it. So what I did, I downloaded again in here on the right hand side in manage palettes. I typed in search NMEA, and then I downloaded and installed this nodered contrib NMEA, and then that gave me a node in here somewhere. It's probably in inputs. Can't remember where that is. If you can't find it. So that's one of the nodes that I've dropped in, and then in here it's going to input a payload and then it outputs a payload, but it gives you a bit more human readable. So I've just now deployed a load of them payloads. So it takes in that string of data and converts it into this sentence. So it strips out all the data and then gives you a longitude, a latitude, whether you're on north or east or south and west. Gives you an altitude units, how high above ground you are, whether you've got a decent fix, and so on. But then there is also, that's the sentence GGA, and if you look at as well, there's a sentence RMC. This is more the information you're after. It gives you a little bit less information, but the information you need. So what I do, I send that information now into a change node. So these change nodes, it takes the message payload lat, because what comes out of here, let's move that out a bit more. You have a message payload lat. So the longitude and latitude is what you really need. So you can either click on here, you've got copy path, copy value, or pin open. Well, I'm going to pin it open, but you don't want to copy the value. You just need to know where it's coming from, because the value is going to change all the time as you're moving. So you just copy the path and then paste it in here. So message payload lat. So the message is the message coming out of the TCP port going through the NMEA processor, and then it spits out this. So this is, the whole thing is an object, which the object is the message. So then you take message and then it's a payload. All these are payloads of information. So then you take the message payload lat, or you can go message payload lon, but everything is case sensitive. Yeah, you cannot be writing capitals and expect to get that information. It has to be written in the case sensitive it is in. So if it's all in lowercase, it needs to be in lowercase. If you have lowercase and uppercase mixed it together, you have to write it like you wrote it. Like this one here. I write with capitals and non-capitals at the different words to give me the right it's easier to see. So then you want to move that message payload latitude to the message payload, and then spit it out. And then also you want to set the topic to latitude, because later on you're going to need a topic in there, because when we bring these information back together, because if I spat this information here into the tracker's information, it's just it's not going to like it. Yeah, it needs in its own little format, and this is how I'm starting to process the information. So I've done one of these for the latitude, and then click OK, and then I've got one for the longitude. So now what you do, you feed that information. What is this doing? You feed that information twice. You take the information once out to here, so every time this one gets a message, this one gets a message. It's an identical message, but what comes out of this is different. So where we had all this information before, now we're just getting 2 seconds. I'll just get it down to the bottom, and now we just get a message payload with just the latitude. Obviously, if I put complete message object on there, it will show the topic and other bits and pieces, but not to worry. So now we need to join that and the longitude together. So because we only wanted the longitude and the latitude to start off with, we didn't need all this extra information, which is, yeah, it's handy to have, like the timestamp and stuff like that, but it's not really worth dealing with it. So you trim out the fat. So now what comes out of here is just the longitude and latitude. They get joined together, and this is where the topic came in. So where we got the topic in here, it'd just be the longitude and latitude topic. What it'd do, it'd combine two message payloads, or how many message payloads you're asking for. So after a number of message parts, 2, because I've only got 2 parts to the message, longitude and latitude, and then the key value is object. So it creates a key and a value object using the value of the message topic. So the message topic will say longitude and message topic will say latitude in there. So you don't see that there, but that it is there. It's in the complete object. So it'll take all of those information and then spit out. And I'll just go to the complete message object so you can see. And then out comes a bit of information, and then the payloads. So this is what comes back. So it always leaves a little trace of how it's got to me. So it tells me it's come from a TCP port. The ID that there is actually probably the MAC address of my router. Or some ID that the router knows, like the connection with a bit of a mixture of the MAC address. And obviously the message ID is, each one has a unique ID. So, but now it's joined the 2 payloads together and just put longitude and latitude. Now, but the world map can't completely deal with that just as it is. It needs it formatted ever so slightly differently. So this is where we use a function node. The function node takes the message payload, and then at the top you put return, which means you want the message, a message back, and then that's why I've got return message at the end. So the message, and then because it's in brackets, it means the message is made up of the longitude, the latitude, the registration number of my vehicle, time, the message payload time, and popped true. So you can either put false there as well if you wish. The popped means it gives you a pop-up window with all this information in, but it doesn't show you this information, it shows you this information over on the right hand side, so the longitude and the latitude, and it'll give it a little title. So come out of there, just hit deploy just to freshen it up, and now this is what comes out of here. So, and this is how every time that comes out, that's an updated point. So on the right hand side now, this is how it comes out looking. So time unidentified. It doesn't matter about the time so much. You can put it in, you can take it out. I haven't to put it in at the moment. There's just no need for it. Then I've got two world maps here. I've got the mobile and I've got the desktop app. The mobile is obviously for a mobile phone, and the desktop is for a computer. So the world map now spits out a location. So you can either zoom in, zoom out, but every time that's updating, that's an updated point. And then on top of that, so I'll just show you again, you need to go back to here, click on this, manage palette, and because world map's not in the system, we need to add it in. So you type in WORLD map, and then because I've already installed it, it's come up to the top, and then you just hit install and it'll give you the extra nodes that you need to put it on. And then on the information here, if you click on a node, it gives you information about that node. So the world map, it requires a name. So the message payload must contain a name, longitude and latitude properties. Yeah, you can put the time in, you don't have to put the time in. You can put all of these different optional add-ins if you wish. It's not a problem. But you go into here and then you can set up how the size of the page, what map scales you want to use, whether you want to use grayscale, color maps, you want to use European satellite imagery, UK OS, open data. It all depends what maps you want to use. It's your choice. And then the overlay is selected, so I've put rainfall, day, night, and so on. So you can have different overlays in, and then you can have the scale. So the different types of layer, how it's zoomed, whether you can zoom in or out, whether if it's locked, you just put enable and it'll lock the zoom to a certain scale. And then remove markers after a certain amount of time. What you don't want to do is build up too much memory usage. So after 600 seconds, you want some of them markers gone. It doesn't matter about those markers. We're saving them somewhere else. So I'm going to show you where we're saving them now. So on top of that, I wanted to get that data into the Victron Cerbo now. It's in the Cerbo, but it's not recording it as a GPS. So then I sent that data via this link out node, and then that will link into a link node. So if I click on that, it'll take me to the link in. So again, I've got the switch node because I want some extra information. So I want the RMC and the GGA. The reason I needed the GGA is there's some extra bits that the Victron required. So I'll take that information into here. Let's get rid of that. And then we have some new nodes that Victron gave us quite kindly the other day, instead of me having to make my own. But we have custom input, custom control, virtual devices, the virtual switches, and inject notifications, and VRM APIs. Well, I wanted to add a GPS to the actual Victron, so then when it goes onto the VRM, it actually records my location instead of having a USB GPS plugged in. I mean, you can have a USB GPS plugged in, but I thought, well, I've got a router with a GPS in, and I didn't want to use up all the USB ports. I know you can use hubs, but Victron kindly gave us this virtual device node. So you click on the virtual device node, you drag it onto the screen, and then you've got name, and then you name it router GPS and device. Obviously there is other devices in there, but because this one is running, it won't allow me to change it. So if I bring in a virtual device down here, and then you can come in here and you can select what type of device you want, whether it's an AC load, battery, an E-drive, generator, GPS, grid meter, Meteo, whatever that is. Don't ever remember seeing one of those, but PV inverter. So if you've got a specific type of inverter that you use, that you want to use, but Victron doesn't support it. Well, they do now, but you do have to do a bit of messing around. So if your non-Victron inverter or PV inverter has Modbus or something along those lines, you can pull that information in. It's a little bit more advanced for this sort of what I'm showing you here, but the GPS is the easiest one to do. So this is going to want some information, so we'll cancel that. I'll bring back I want the information node or help node at the side. Stay up. There we go. And then you click on the GPS and it should give you some information about the node. No, it's not. Okay, well, it needs... Oh, sorry, yeah. So once that just creates the virtual device, and then it gives it a virtual GPS and code 100. So then you need to feed certain amount of information into this device. So then you go custom control, as far as I'm aware, yeah, custom control, and then you control the virtual device, which would be down the bottom here. Virtual GPS or router GPS, and then it's going to want all of these measurements coming in so it can do its thing. You don't have to have like the processor version and bits and pieces, but it's going to want a fair amount of information for it to show up in here. So in here, you can tell I'm new to a Mac. Let's go back to full screen. For it to show up in here, you need on the settings, devices, and then router GPS. You can click on it. It's the basic information it's going to want. It's going to want status, longitude, latitude, speed, altitude, and number of satellites connected. It's going to need all of that information, otherwise it's not going to really save it properly. So once you've got all of that information processed, where were we? So I've got the fix, the speed, number of satellites, altitude, all coming out of these nodes, getting processed, and then getting sent into that device. So every few seconds, these are updating. I think they're probably every once a second. And then the bonus of getting it into here and all the virtual devices is you haven't got to store the data. The data is stored by Victron, on their VRM. So they'll upload the whole lot to the Victron's VRM. So you ain't got to store nothing. As long as you've got a Victron device of some sort, Victron will store all the data for that device as long as you've got a Cerbo. And it's free of charge. Had no issues with recovering data from them as well, which is pretty good. So that's the GPS. That's going to be it for now, but the Truma's a lot more advanced. That all works on MQTT. That's a video on its own. So I created an ESP32, wrote some MicroPython code, and a little bit of machine language because it was quite a lot of code. Couldn't get it all in on MicroPython. I had to keep the whole file below 4 megabyte for everything, and MicroPython weren't going to allow it all to be below 4 megabyte. So I wrote a big portion of it in machine language, put it on an ESP32, connected that so it dumped all the information from the Truma to the cerbogx MQTT server. Like I say, that's a video on its own, but I can actually control my Truma via switches. So I've got my heating on, hot water on, gas. I've got a selector between gas, mix 2, electric 1, electric 2 kilowatts. I basically only put on there what I use on it. I could have put the fan just to come on and the blower, but I haven't got round to it. And to be honest, I hardly ever turn it on now. I've got the air conditioning. And then I'm running a multi plus 2 3 kilowatt and a multi plus 2 2 kilowatt. They're both inverter mode at the moment. Plus I've got the just a small inverter just for doing very, very small devices, and that's never turned off. Plus I've got the temperature of the hot water in the hot water tank for the Truma. There's my hot water on. Okay, better turn my hot water on. Okay, well, I'm going to leave it at that for this video. I may add a little bit more in a minute, but we'll speak to you later.